All right, this is section 5.2. We're going to talk about exponential functions. And exponential functions means that the x is in an exponent. So if you look at these problems, the exponent is, in this one, 2 to the x power, 1/2 to the x power, and 3.57 to the exponent. That makes them an exponential function because the exponent is where the x is. All right, let's go to the next page. So we want to graph an exponential function. In order to graph an exponential function, we're going to use a t-table just like we've done in other instances. So when we make our t-table, we need 3 values in it. And we want to take the exponent, or the exponential part, and we want to set that equal to 0. So we're going to put 3 values in our t-table, and the first one is with the exponential, which the exponent equaling 0. So we put a 0 there. Then you go down 1, and you go up 1. Now you find f of all of these. So we're going to find f of, I'm going to start at the bottom and find f of 1. So f of 1 will be 2 to the first power, and 2 to the first power is 2. So a 2 goes in the t-table. F of 0 gives us 2 to the 0 power. Anything raised to the 0 power is 1, so we get 1. And f of negative 1, that's 2 to the negative 1/2 power. And remember that a negative exponent becomes a positive exponent when you flip the fraction over. So you take 2 over 1 and make it 1/2, and that's what goes in the t-table. Now we're ready to plot these points on our graph. So we've got a negative 1 and a positive 1/2, which is here, and 0, 1, which is here, and 1, 2, which is here. And then you connect those, and the exponential curve looks like this. And there it is. Now, an exponential curve has a horizontal asymptote, and the horizontal asymptote in this curve is right here. What is an asymptote? It's a line that a function approaches. It usually doesn't cross it. It gets closer and closer and closer to it. So the equation for the horizontal asymptote would be y equals 0. So y equals 0, and your homework's going to be asking you for that.